A generative language artificial intelligence model is a model that learns from vast amounts of text data and generates new text. This model is based on deep learning and operates by predicting the next word. First, the model takes in extensive text data for training. This data can be collected from various sources such as books, articles, code, emails, and more. The model learns the relationships between words and the context between them from this data. Once the training is complete, the model can generate new text. It predicts the next word based on the input text, relying on the relationships between words it has learned. Generative language AI models can be applied in various fields. For example, they can be used to create creative content. They are also valuable for natural language processing tasks like translation, summarization, and question answering. To provide a more detailed explanation of how generative language AI models work. Input data. Generative language AI models are trained on a large volume of text data. This data can be sourced from a variety of places, including books, articles, code, emails, and more. Training. The model learns the relationships between words and considers not only word order but also word meanings and context based on the input data. Generation. Once training is complete, the model can generate new text. It predicts the next word based on the input text, using the word relationships it has learned. Generative language AI models are still in their early stages of development but hold significant potential for use in various fields. Generative language artificial intelligence models are models that generate natural language by learning from vast amounts of text data. These models can be broadly categorized into two types. Transformation models. These models convert input text into output text. For example, they can perform tasks like translating English to Korean, composing poems, or generating code. Generation models. These models create new text without the need for specific input data. They can be used to write creative content, craft stories, compose music, and more. Generative language AI models are built on deep learning technology. These models utilize patterns learned from input data to generate new text. For instance, an English-Korean translation model learns grammatical and semantic patterns between English and Korean by training on data in both languages, enabling it to transform English sentences into Korean. These models find applications in various fields, including translation, creativity, education, marketing, and more. The operating principle of generative language AI models can be broken down into the following steps. Data collection and preprocessing. Initially, a large volume of text data is collected, which can be sourced from diverse origins such as books, articles, blogs, code, music, poems, and more. The collected data undergoes preprocessing to prepare it for effective learning. Model training. Based on the collected and preprocessed data, the model undergoes training. During this phase, the model learns the relationships between input and output data. Text generation. Once trained, the model is used to generate new text. In this process, the model predicts the next word based on the input data. Generative language AI models have certain limitations. Bias. These models can reflect biases present in the training data, potentially generating biased or discriminatory content. Error propagation. Errors within the training data can lead to the generation of inaccurate or misleading information. Creativity constraints. Models typically generate text within the scope of the data they were trained on, making it challenging to produce entirely novel or creative content. Generative language AI models are rapidly evolving, and ongoing research aims to address these limitations. A generative language artificial intelligence model is a model that learns from large-scale text data to generate new text. This model operates in two major ways. Sequence-to-sequence model. The sequence-to-sequence model is a model where input sequences correspond one-to-one with output sequences. For example, a model that takes a sentence in Korean as input and outputs a sentence in English falls under the sequence-to-sequence category. This model processes words from the input sequence one by one, predicting the next word in the output sequence. To illustrate, if given the Korean sentence, "원울린 날씨가 좋아요," as input and aiming to produce the English sentence, "The weather is nice today," the model predicts the next word as follows. Input. 원울린 날씨가 좋아요. 1. 원울린. 2. 원울린 날씨가. 3. 원울린 날씨가 좋아. 4. 원울린 날씨가 좋아요. Output. The weather is nice. The weather is nice. The weather is nice day. The weather is nice today. In this manner, the sequence-to-sequence model generates new text by predicting the next word in the input sequence. Generative Adversarial Network, GAN. A generative adversarial network, GAN, consists of a generator and a discriminator. The generator is responsible for creating new text, while the discriminator's role is to determine if the generated text is real or not. These two models compete and evolve together. The generator strives to produce more realistic text to deceive the discriminator, while the discriminator works to better distinguish between generated and real text. Generative adversarial networks have a more complex structure compared to sequence-to-sequence models but offer the advantage of generating text that is more realistic. Generative language AI models have diverse applications, such as translation, summarization, creative content generation, and can also be employed in conversational AI, such as chatbots and virtual assistants. Generative language AI models are still in their early development stages, but they hold the promise of bringing various changes to our daily lives as they continue to advance.